The eternal question, where do we come from? Humans have gazed at the stars for millennia. We have wondered about our place in the cosmos. The question of our origin is deeply ingrained in us. It is a question that has been pondered by philosophers and scientists alike. Where did the universe come from? How did life begin? For centuries, these questions were the domain of mythology and religion. Ancient civilizations wove intricate stories to explain the existence of the universe and humanity. These stories, passed down through generations, provided a sense of comfort and understanding. They offered explanations for the unknown and gave meaning to human existence. However, with the advent of modern science, new ways of exploring these fundamental questions emerged. Science, with its emphasis on observation, experimentation, and evidence-based reasoning, offered a different approach to understanding our origins. It provided a framework for investigating the natural world and unraveling its mysteries. Today we stand at a crossroads of knowledge. We have made remarkable strides in understanding the universe and our place within it. Yet the fundamental questions of our existence remain a source of wonder and debate. The quest to comprehend our origins continues to drive scientific inquiry and inspire philosophical reflection. The Big Bang Theory is the prevailing scientific model for the universe's origin. It suggests that the universe began from an extremely hot, dense state about 13.8 billion years ago. In an instant, space itself expanded rapidly, cooling and creating the universe as we know it. Imagine the entire universe compressed into a point smaller than an atom. This tiny point, incredibly hot and dense, suddenly began to expand. This expansion wasn't an explosion into pre-existing space, but rather the expansion of space itself. As the universe expanded, it cooled. Energy converted into particles, forming the building blocks of matter. Over vast periods, gravity pulled these particles together, forming stars, galaxies, and planets. The universe, once a uniform sea of energy, transformed into the structured cosmos we observe today. The Big Bang Theory is not just a guess. Scientists have gathered substantial evidence to support it. This evidence comes from observations of the universe's expansion, the cosmic microwave background radiation, and the abundance of light elements. These observations align with the predictions of the Big Bang model, providing compelling evidence for its validity. One of the most compelling pieces of evidence for the Big Bang is the cosmic microwave background radiation, or CMB. This faint afterglow of the Big Bang permeates all of space. It was discovered accidentally in 1964 by Arno Penzias and Robert Wilson, who initially thought their antenna was faulty. Imagine the universe just a few 100,000 years after the Big Bang. It was a hot, dense soup of protons, electrons, and photons. As the universe cooled, these particles combined to form neutral atoms, primarily hydrogen. This transition allowed light to travel freely for the first time, filling the universe with a faint glow. This ancient light, stretched and cooled over billions of years, is what we detect today as the CMB. It carries the imprint of the early universe, providing a snapshot of its state shortly after the Big Bang. The CMB's temperature and uniformity across the sky align remarkably well with the predictions of the Big Bang Theory. Another key piece of evidence comes from the observed redshift of distant galaxies. Redshift is the stretching of light waves as objects move away from us. The farther away a galaxy is, the faster it appears to be moving away. This observation suggests that the universe is expanding, a key prediction of the Big Bang model. While the Big Bang explains the universe's origin, the origin of life on Earth remains a fascinating mystery. The transition from a lifeless planet to one teeming with life is a complex process called abiogenesis. Scientists are still working to understand how it happened. Imagine the early Earth, a volatile world bombarded by asteroids and comets. Volcanoes erupted, spewing gases and lava. The atmosphere was a toxic mix, devoid of the oxygen we breathe today. Yet in this harsh environment, life emerged. The prevailing theory is that life arose from non-living matter through a process called chemical evolution. Simple organic molecules, the building blocks of life, formed in the primordial soup of early Earth. Over time, these molecules assembled into more complex structures, eventually leading to the formation of self-replicating molecules like RNA or DNA. These early life forms were likely simple, single-celled organisms, but from these humble beginnings, life diversified and evolved over billions of years. The process of evolution, driven by natural selection, led to the incredible diversity of life we see today. While we don't have all the answers, scientists are making progress in understanding abiogenesis. Experiments have shown that organic molecules can form under conditions simulating early Earth. By studying these processes, we hope to one day unravel the mystery of how life began.